It's worth revisiting at this stage what we actually mean by a mole. A mole is the number of atoms in exactly 12 grams of carbon-12. That's to say, a sample of carbon where every atom has 6 protons and 6 neutrons. At this point, it's just worth pointing out that over the next couple of slides, I haven't spelt Avogadro correctly. Please excuse this, but it's very difficult to change once it's in the sequence of videos. I apologise, especially to Senor Avogadro, who wasn't even Spanish, by the way, he was Italian. The number of atoms in exactly 12 grams of carbon-12 is 6.022 times 10 to the 23. This is a rather large number. This is called Avogadro's number. It is such a big number, it's worth writing it out as 602,200 million approximately 600,000 million particles in a mole of any substance. And that number has not been chosen by chance. It so happens that a mole is that quantity of a substance whose mass in grams is exactly the same as the relative formula mass of that substance. For example, iron, whose relative atomic mass, which as for a metallic element counts as its relative formula mass, the relative formula mass is therefore 55.85, and therefore 1 mole of iron has mass 55.85 grams. That means 55.85 grams of iron contains exactly 600,000 million atoms of iron. 2 more examples. 1 mole of water contains 600,000 million H2O molecules. And 1 mole of sodium chloride contains 600,000 million NaCl units. And therefore we can use Avogadro's number to find the total number of particles in any amount of any substance. Chemists find the mole really useful as a concept. It's easy to talk about 1 mole of water rather than 6 times 10 to the 23 water molecules. Now you might think, well surely it would be easier just to refer to the mass in grams. However, when chemical substances react together, it's not the mass which is important, it's the number of particles. So, if you look at any equation, like for example the equation by which ammonia is produced from nitrogen and hydrogen, it's useful to be able to read the equation as 1 mole of nitrogen reacts with 3 moles of hydrogen to make 2 moles of ammonia. And because of the relationship between the mole and the relative formula mass and the actual mass, I know from writing this that 1 mole of nitrogen is the same as 28 grams of nitrogen, because the relative formula mass of N2 is 14 times 2, which is 28, and 3 moles of hydrogen is 6 grams, because each hydrogen molecule has 2 hydrogen atoms, and the relative formula mass of hydrogen is therefore 2, and 3 moles therefore weighs 2 grams. It's then a very short step indeed to work out that 2 moles of ammonia, where nitrogen has a relative atomic mass of 14 and hydrogen has a relative atomic mass of 3, 1 mole of ammonia has mass 17 grams, therefore 2 moles of ammonia has mass of 34 grams. So by looking at the equation, a chemist would very quickly be able to work out that from every 28 grams of nitrogen put into the system, one should get out 34 grams of ammonia. And that is really, really useful if you're making things.